We can also look at a charge and correlate it or make it similar to a current. But the charge is just a current flow of one, and if it's moving, then we can simulate it or use it just like a current. And so the charge is going to have the same kind of effect. So if we have a positive charge that goes through at a certain velocity through a magnetic field, it's going to experience a force in the same way of the right-hand rule as the charge goes through the magnetic field. The negative charge is going to experience the opposite direction, so it's going to be opposite the thumb in the right-hand rule, and it will go down. And so the equation that we can use is very similar to what we did before, and that's the force is equal to the charge times the velocity vector cross product with the b vector. And so we notice that we can get this by taking our force for the current is L cross B. And if we define the current in terms of charge, we get dq over dt times L cross B. And now I'm going to change my differential. If I change it to L, then the Q just comes out as normal. And the derivative of length divided by time gets us back to our original cross product for the charge that we used. So we understand now how the force is related to a charge and to the velocity. Now, this can have some interesting results. If you take a negative charge and you put it into a constant magnetic field and it's moving at a certain velocity, the force due to the right-hand rule, remember we're going to do the direction of the velocity and then move our fingers towards the direction of the magnetic field, and our thumb would be going outward, but because it's a negative charge it's going inward, and so this creates a centripetal force that's directed towards the center of a circle. As long as the electron maintains a constant velocity, it will have a circular shape. And we can see this experiment done. These two large red coils are producing a somewhat constant magnetic field. So there's this coil here, and there's this coil back behind. And this glass tube is in between them, and electrons are excited inside the glass tube, and they will have a certain velocity due to that excitation, and you see this circular path that the electrons are taking. So we'll talk more about how this can be useful in other sciences, both physics and chemistry, when we talk about some of the applications.